Okay, and we are live.
Lovely.
Okay, great. Hi, folks. How are you doing? I'm Eldon here with Khalil again. So today we're going to talk about a very exciting issue that we are basically following up from the previous session, which is with the case where a certain machine might not have a GPU, the other machine might have a GPU, and they want to collaborate on a project, right? So hopefully Khalil will guide me through the process, and I've never done this before, so hopefully it will be a nice sort of video. Hi Khalil, welcome.
Hey, nice to be here again. Yeah, it's been a week already. Time flies, but it's a good thing because I've been eager to get back here and make some progress on that project. I feel as if we're going on turtle speed, but at the same time, things are going to ramp up very fast very soon. So it's better to start very slow on the onset. So if you recall last week where we were was we created a virtual environment using Conda, and we pushed that virtual environment to GitHub, and Mehran pulled that virtual environment down to his machine and attempted to set it up. There was a slight glitch, which we will get back to, but the good thing is eventually he was able to get it to work. But today's session is about something different. What we're trying to do is to accommodate a situation where his machine is different from my machine. I'm running on a MacBook. He's working on a Windows machine. I don't have a GPU. He has a GPU. So how do we cater for such differences? And are such differences common in real life scenarios? Yes, they are. Very often you find in a team, people choose operating systems that they are most comfortable with. So it's very likely that someone has, a Unix environment, another person has a Linux environment, and one person has a Mac environment. But even if everyone is using the same system, because the life cycle of your model starts from development and then goes to some sort of testing environment, whether it's QA or staging, where you have people double checking, and then it could go into some sort of engineering environment where you have machine learning engineers trying to optimize your model, and then it graduates to maybe production, where your model is actually doing what it was designed to do while facing a real life scenario. So across this life cycle, it's very likely that dependencies might vary. And it's very likely, for example, in testing that you're using a certain set of packages to track, performance, but you don't need that type of tracking in production. So you see the package that does the tracking in the staging environment will differ from the package that is doing the tracking on the production environment. So we're going to set up the project in such a way that it will accommodate for different flavors of deployment environments, whether it's staging or testing or Windows machine versus Unix machine. So let's get started. So from last week, what we did was Mehran had already set up the VAE environment. So we're going to nuke that environment. We're going to try and make some modifications to the environment.yaml file so that he's using a GPU version of it. And then he's going to push his changes back to me. And once he pushes his changes back to me, I'm hopefully going to be able to create a wrapper, which is just, a neat entry point, a single command that you could type to say, I want to set up a machine. I want to set up a virtual environment for a Mac machine or for a Windows machine, GPU or no GPU machine. So Mehran, when you're ready, it will be good to open up your terminal. Let's get cracking.
Okay, yeah. Before we get cracking, what does nuking an environment mean?
Delete your environment.
Oh, I thought the word was a little bit aggressive, but so that's exactly what it means.
Yeah, I've heard all sorts of weird names for it. Some you can't even say on stream, but yeah, I think totally getting rid of it. Totally.
All right. Okay. By all means, I'm gonna get rid of. Maybe I can just do it with this git. A minute. Hopefully, all the commands work here. So it should be visible, right? Should be.
Yes, Claire.
Grand. Okay. So and okay, it's VAE we want to get rid of.
Yes.
I don't know the command by heart. Do you?
So it's conda env, and then do a double hyphen help. So let's ask for help. Good. So you see there's like create, export, list, and remove. So what we want to do is we want to remove the environment. So what we need to do is conda env, remove, and then VAE.
Bye. Done, right?
No. I think we missed something, right? Because the name, so it's going to be conda env remove. I think it's double, either a single hyphen N or a double hyphen name. Yes, VAE. I'm guessing. Let's see.
Okay, it's a good sign. It's taking some time.
I hope so.
I suppose some of these delays might be attributed to the fact that Windows sucks. Okay, good.
I don't think so. I think there could be a lot of explanations to it, but
Windows sucks as well. I mean,
they've been improving their game. To be fair, they've done a lot. For example, you have Ubuntu now shipped as part of Windows, right? So that's a huge improvement.
Okay, so right now, just to be clear, so conda env list doesn't have the VAE environment anymore. So the star says that the base environment is activated.
Exactly.
Right.
So the next thing also is we made changes to the environment.yaml file. So we want to undo those changes.
Yeah. Can I just point out something here? Actually, guys, I was talking to Khalil last week, and he mentioned something that I didn't know about, coding in general, that even though I have not made any, so I have not committed the changes that I've made to the cloned repository on my machine, those changes were in the actual environment file. I had not committed those changes, but to my amazement, Khalil said that even though you haven't committed, you can always retrieve back. So I'm really eager to see how that will happen. Let me just go into the repository. I think that would be the right place to be for now. Okay. Now I'm ready.
Good. So let's see. You want to do like a git status to see if you're actually in the right place. So you're not there. So you want to
what the?
Yes, you are in the wrong place.
Am I?
Yep.
But that's the environment.
So, no. Now you need to drag VAE. So the direct path is now.
Oh, sorry.
Yes.
Sorry.
So you want to clear that? Yeah. Good. Okay. So now git status. So you can see that the environment.yaml file has been modified the last time you worked with it.
Yeah.
So to undo this, what we want to do is you either run the command git restore to restore the file, which is actually a very intuitive name, or you can just do a git checkout and then specify the environment.yaml file. So let's do a git checkout. Let's go old school. Git checkout and then environment.yaml.
That's it?
Yep. So what it does is it goes back into your repo. That's the previous version of your repo before you made any changes to it. And then it checks it out. It just picks up the file and copies it over to your working environment.
But how does it know how many steps it needs to go back?
Because you specified a single file. So there are 3 stages on your machine at the moment. There is your working directory, which are files that are not being tracked by Git. Okay. Then there is a staging environment, or staging environment would be a good way to say it. And what happens is any changes you make that you want to track, those files will be logged in the staging environment. And then there's your local repo. And you think of that, the best way to think of that is as a database. Okay. So you start in a place where you're not tracking anything, you track, and then you push it to your database. And if you make a change that you don't like, what you want to do is you want to start from the working directory. So you pull from your database back to your working directory. So I'm trying to see if there's a good analogy to use here that would make sense.
Can I just mention something? So I get the idea of, okay, find sort of you like it looks at all the changes that have been made to this file, for example, and then goes back. My question is, those changes would have happened in like discrete sort of steps.
Yes.
And different timestamps. Like, is the default like go to the very like the birth of this environment? Like when you clone this, go to the initial stage, always.
So yes, that's what's happening here. What happens when you commit a change? Git takes a screenshot or a snapshot of your current file system in that particular directory. That's what happens. So anytime you do a checkout, what it does is it goes back to that snapshot and gets the last version that was committed, the last version that was saved, which means if you had done 5 changes to environment.yaml, those 5 changes will be overwritten or will be discarded so that the file goes back to the way it was in the last snapshot.
So if I had like 3 commits in environment file, for example, right? And I wanted to go have the option of going back, then because I've made commits, I'm able to actually say go to which commits, like before I made which one of these commits.
Yes, you have that flexibility. So you could jump to a particular commit, whichever way you want it to be. There, it's just an unlimited number of snapshots that you have with each commit that you make. And because all Git is doing is just unzipping files and putting them in that particular directory, you can go back or forward as much as you want.
Okay, that's great. Okay, so now, we did check out.
So if you do a git status now, the repository should be the same as it was when you pulled it down from GitHub. So
nice. It
contains the changes that I had made last week.
Okay.
So what we want to do now is create this environment, a new environment.yaml file for GPU machines, particularly your machine. So we want to open environment.yaml.
Oh, okay.
Yes.
Just open this.
Yes. Good. And then you want to delete scikit-learn for now.
Okay, guys. So in order to work with the Vim editor, I have to press I so that I can actually do edits.
Yeah. So you can escape. Sorry, there's a shorter way. Just press escape key.
Escape, okay.
Okay, go down to scikit-learn, the line with scikit-learn. Okay, now press DD twice. Okay, you can press the dot button and that will delete that line as well. So it will repeat the last command.
Press dot button.
Yes, good. So you look surprised.
Yeah, because like, what the hell? Listen, I'm like, I had not, so before, pressing I to be able to edit the file, if you press DD, it deletes a line.
Yes, it deletes a line.
And if you press dot.
Yeah.
What happens then?
It's beautiful. We can do a session on Git.
Yeah, we have to, man.
what it does is it gives you wings. It's like programming on steroids, and it's a very lovely editor. Like if you go to, can you press D, then T, then
Like,
1? It's just one after the other. D, T, 1. So what it has done, it has deleted up until the number 1. So you can press U to undo, and you're back where you were.
Jesus. No, we have to do a video on this.
Yeah.
Okay, anyway,
so
let's go on. Yeah.
Let's leave it as it is at the moment. Don't save the changes yet. What you want to do now is open the PyTorch web page to get the package name for PyTorch GPU.
Okay. Do we need to explain why we got rid of the scikit-learn line?
Yes. So we're going to start with the least amount of information, or the least amount of packages, and then we're going to add stuff progressively. And this also sets the stage for the refactoring that I will do later, because what happens is there's a base requirement, which is JupyterLab, scikit-learn, SciPy. And then on top of that, there is either a CPU set of dependencies or a GPU set of dependencies. So what you're doing now is just ensuring that the GPU set of dependencies are installed. And then once I start making those refactoring, you'll understand why we're getting rid of those lines.
Okay. Stable version, Windows, Conda, Python. I forgot my CUDA version. Just 1 second. Just 1 second. I'm gonna activate one of the environments that I already had, and I'm gonna go Conda list. This is an existing environment, guys. I've done tons of stuff in here. So I presume I should see my CUDA version here.
Yep.
CUDA.
Seems to be 9.0.
Yeah, but that's weird. Or maybe it's not, because this is an old laptop. This is not my actual work laptop. Maybe that was the version. Do we even have? We don't have 9.0 available on PyTorch.
Not anymore.
All right. So let's just go with the lowest version. Hopefully it will be okay. So CUDA 10.2, eh? We can just please use CUDA what? Oh, this is no longer available for Windows. Okay, let's go for this. Hopefully it will work out. If in the future, when we are actually coding VAEs, if this didn't work out for running on GPUs, I'm gonna switch to another laptop and we can continue with that.
Is it possible for you to run the NVIDIA SMI command to see if we can get the CUDA version?
Yeah, on Windows, I'm sure it won't recognize the command because it's Windows.
Oh, okay, makes sense.
What about this guy?
You want to do Command Z, Control Z?
Oh, Control Z.
Yep.
Did it save and?
No, it just froze it and sent it to the background, so we can bring it back to the foreground later. Yeah.
Nice. So I want to know whether I can run it here. No.
No, you don't. Okay, so FG will bring it back.
FG.
Yes. Okay.
It's crazy. All right. Yeah, so let's just go with this version.
Yes, let's try that.
Yeah, so this is the command. Copy. So what should we do here?
Okay, so sorry, can you go back to it again? So it's PyTorch. Okay, so what we want is we want to copy CUDA toolkit 11.3, that particular. So what I'm going to copy, in fact, copy the entire command, okay? Copy the entire line, okay? Now go back to Vim or VI, okay? You want to press escape and O, okay? And then you want to paste it. I don't know if the pasting should work, but let's see. Oh, it does work. Okay, grand. So, so you want to press escape, and then it's easier if I have control. And then you want to press 0. Good. And then W. Okay. Now an I. Backspace. Okay, hyphen. Good. Okay, grand. Now D. Okay, escape. Then DW. Again, dot.
Dot?
Yeah, just dot. Dot. Keep pressing it. Yep. Again, again, again. Good. Now in space. You are I then space, sorry. So you want to go to, yeah, good. And then escape. Okay. Then you want to press W so that you jump to the next word. W again. W again. Okay. Now press Shift D to delete everything. Good. Okay. So now you can save it. So what we've done now is we've pulled the only package that needs to be installed to allow CUDA, PyTorch to work with CUDA. Okay. But before we do that, we need to double check that our PyTorch version, which is 1.2.1. I don't think we need to, but I'm certain that PyTorch 1.2.1 works with CUDA toolkit 11.3. So the PyTorch we pulled is the latest one. This is why I said the check is not important.
Okay.
Yes. Because it's, look at it up there. So the line before, the line preceding the bold line in the paragraph above. So not fully test 1.12 above the bold, yeah, there, the line. Okay. So that's the version number.
Okay. So what should I?
No, we don't need to do anything.
Okay.
I was just double checking to make sure that's the right version. So you want to escape, then colon W Q. So you're going to write and quit.
Okay.
Okay, good. So now you have your environment.yaml file. We want to see if this installation will work, right? Because we don't have a virtual environment anymore. We have an environment.yaml file, hopefully one that can set up a GPU environment. So we need to create a virtual environment using that environment.yaml file. And to do that, you run the conda env create like we did last session. Okay. I think it's F. Okay, just F, yes. And then environment.yaml. So what we're doing now, if you run this, is we're testing to see if we can create an environment using the environment.yaml file. So let's see, that works.
So we're not going to create a duplicate of the environment yet, the file yet?
No, not yet.
Okay, so press enter.
So that should take a few seconds to run if it works well. So in solving environment, again, what it's doing is it's trying to see if there is any conflicts in the packages you're trying to install at the moment. Because it's installing, it means there aren't any conflicts.
Okay.
So there's one thing we need to do, but I guess we can wait for it to finish. Because my thinking was that we shouldn't be pushing code directly to the main branch. What we should do is we should be pushing code to sort of, a work branch and then eventually merge into the main branch. So we're going to do that after this installation works.
Okay, good.
Yeah.
Good.
I'll expand on that.
Yeah, that'll be fine.
Yeah.
I was waiting for it to actually install the toolkit, CUDA toolkit.
Yeah, I'm as surprised as you are. But let's see what happens once it's done. Then we can.
You know how I do this part? I always like get everything else from the file, like YAML file, recreate the environment, but I locally install PyTorch.
Okay.
That's always what I do.
Interesting. And why have you done it that way all this while?
Sorry?
Why have you installed it that way in the past? Like, why install PyTorch separately and then create an environment for...
Well, because of problems like this that might have happened, like, you know, like, so things that are really specific to my machine. PyTorch's installation is really sensitive to what machine you're working on. So there was no sense for me to, like anybody who was generating that environment file, like their machine would be totally different.
Oh.
So that's why I just said, get rid of that line. I'm gonna install it myself.
So, okay, so you install all the packages, including CUDA toolkit, separately.
Yes. No. So everything according to the file, but installing PyTorch, like literally running the entire line from PyTorch's website.
Oh, got it.
In that created environment.
Got it. Okay. So yeah, hopefully this should give us the same impact. I don't know, because what I'm looking at is it's simply downloaded a few packages. I can't see CUDA in there, but there's one way to find out. So let's activate the environment and peek through the packages installed in the environment.
Conda list, right?
Yes. Okay. So there we have PyTorch. Yes. And you can see version 1.2.1 with CUDA 11.3 and that same line. So I guess what happened here was because we've installed PyTorch before, Conda keeps a cache. Pip does that too, a cache of all those packages it has installed in the past or it has downloaded in the past. And when you try to install it again, it doesn't go off to the internet to try and download most of them. It just kind of installs them.
That's interesting.
Yeah.
So if I were to go Python, why does it keep freezing like this? That's so bizarre.
It is. And what's weird is I haven't seen this before. All it's doing at this point is it's trying to set up environment variables. That's it. It's not doing anything fancy. So again, this is one of the quirky behavior you should expect when working with Windows machine. It's not like they're terrible, but there are still a little rough edges that could be fixed. So can you cancel that and run IPython instead? Is this a new window? Is that a new terminal window?
No.
Okay, so you remember we need to start a new terminal window so that, because in Windows, you know, so that it kicks in. Just Python. So it works.
I don't know, like what, like this Git sort of this bash simulator, is that how you say it?
No, it's a shell.
Yeah.
So this alternative to Cygwin, what it does is it's a program that communicates with your operating system. That's basically what it does. But I think it struggles to update path variables after you create an environment. I think that's what's happening. It's not like it's bad. It's just for whatever reason, because you know it's not designed to work on Windows machine. Well, it's not a first-class Windows machine program. It struggles to set that. So it's a minor issue. If you face such problems on Windows machine, close your terminal window or your bash window, reopen it, and activate your environment. Hopefully that should work.
Okay. Okay, so I just imported Torch. I want to see whether it can see the GPUs on my machine. So this is the command. It should return true. Yes. Okay. So
that's awesome.
It means you can see the GPUs, and yeah, we're good.
Yeah.
And also, like, if I wanted to sort of confirm how many GPUs I have, it again presses like returns 1, which is the case in my machine. Good. Perfect.
Awesome. Okay, cool stuff. So now what we're going to do is, we know that the environment.yaml file has been created. We know that it works because you've tested it on your machine. We know that it's different from the environment.yaml file that had worked in my machine. So to make sure we don't have a clash in those environment.yaml name, we're going to rename your environment.yaml file a tiny bit. So you want to rename that file to environment-gpu.yaml, if that's possible.
Just 1 second.
You could do that from Windows in the interest.
Yeah, maybe I should just keep doing this on Windows, on the Windows terminal.
Yeah.
Why doesn't it go in?
No. Why don't you just edit it from
Oh, you mean the actual thing here?
Yeah,
okay.
from the Explorer here. So just yep, edit. Just add a GPU -GPU. No, hyphen, please. GPU. Good. Okay, good. So what you've done is you've renamed that file. It's the same file. The contents have changed, but it has a different file name. So we go back to terminal now.
Okay.
And then
let's go again with the thing, with the shell. I like the shell better wherever possible. Okay. Yes.
Okay, so can you do a git status to see if it recognizes that we've changed that file? Yep. So notice that it's saying that we've deleted environment.yaml file, but we've added a new file, environment.gpu file.
Yeah.
That's fine. So what we want to do now is we want to create a separate branch. So Git has this concept of branches, which means it allows you to work on different strands, different environments or different isolations within the same project. So essentially, you can start working on one version of the project and feel as if it's not good enough. Then you branch off and create a second version, or branch off and create a third version. And then eventually, when you're happy with one or more versions, you could merge them together. So this concept of versioning, to misuse that term, is what we call a branch. So what we're going to do now is, we are on a main branch, as we can see in your terminal window there. We want to create a different branch called, so it's git branch. No, sorry, it's git checkout. I'm not familiar with the git branch command. Git checkout -b. So we're saying that we want to create a new branch, and we call it create -gpu -env, which is for environment, env. Okay, good. Yep, that's fine enough. Okay, good. And what we do now is, can you do a git status just to see what's in there? Good. So we deleted environment.yaml file, but we did not have to. So we can restore that file. Now, if by restoring it, we'll end up having environment.yaml and then environment.gpu.yaml. So can you do a git checkout environment.yaml? So what we're doing now is we're going to Git's database and telling it to give us back, we want to check out, we want to pull out what it has, all it has about environment.yaml, if that makes sense.
Okay, so just to be clear, we went in, we renamed environment .yaml file to environment-gpu YAML.
Yes.
So in this guy's mind, in this machine's mind, we have erased that. So we have a new one.
Yes.
So you're saying that the history of the deceased environment.yaml is still in the history of that Git folder, that hidden folder.
Yes, it's a database. So yeah, it's in there.
Okay.
Yeah.
So I'm gonna go git check out environment.yaml.
So hopefully it should work. There's a lot of surprises with Git. So can you do a Git status again? Aha. So now it's not telling us the environment.yaml file is missing. It's only telling us that we have an environment-gpu.yaml file. Can you do a list command, ls? You can see we have environment-gpu.yaml and environment.yaml. So environment.yaml is our CPU one, and then environment-gpu.yaml is our GPU one, right? So now what you need to do is you need to add those changes. And when you do a git add with a dot, you're saying, hey, Git, keep tracking changes to environment.gpu.yaml file, okay? So do that. Good. But then, we don't want to add anything to environment-gpu.yaml. So we just want to commit it. So we want to take a snapshot of your directory at the moment and put it in Git's database. So it's git commit m, okay? And then good. Create GPU virtual environment. Good. Enter. And then you want to do, yes, just to check. It's always good to do a status. So our working tree is clean, which means our working environment is clean. Our table is clean. We're ready to go. So you just have to push that now online. So when you do a push, it goes to your local version of the repository, copies all the stuff that is not upstream, which is GitHub, and then syncs it with GitHub. So do a git push.
Okay, so first goes into the local database.
Yep.
And then does what?
And then it looks at all that has changed since the last time you pulled. Okay. And then it pushes it upstream to GitHub.
Okay, gotcha. Just to be clear, I'd like to also show everybody basically like the actual environment. I mean, on GitHub, like we have this VAE repository, and just want to show that, look, all we have here is environment.yaml, and we don't have any branches yet.
Yep.
So if I'm pushing, I think all of these should be reflected. All the changes. So one more thing, I'm right now locally in this branch. So if I want to push, like, should I push to, like, should I create this, create GPU env branch?
No, not. My strategy, I think there's a way to say you wanted to go upstream to a particular branch, but memorizing that command is too hard. So my rule of thumb is to just start with the bare minimum and let Git advise, because Git has a very, very nice error reporting and advisory service. So if you run git push, it will tell you if it won't work. And it will advise you on what to do. Good. So the error message there is that the current branch, create GPU env, has no upstream branch. So it has no location on GitHub to go to, right? To push the current branch and set the remote as upstream, use git push, set upstream, origin, create that. So you can just, yep.
Or do I have to go like that?
Yeah, I just copy and paste it, but it's good if you type it as well.
You're just trying to make me feel better.
Yeah.
Okay. Origin, and then
create GPU.
So it's saying that, look, you are locally in this create GPU env branch, and you want to push it to GitHub, but there is no, I don't know where to go. Like there's no such a branch up there. So it's
Yeah.
saying that you have to do something about it. Like,
Yep.
okay.
Good. So now we go to GitHub and see if our changes have been synced.
Oh, create GPU env had recently pushes less than a minute ago.
Yep.
So should I refresh the page?
No, it means it's there. You don't have to. It's there.
But I wanted to see the
click on view all branches. Let's see. So you see you have two branches, main and create GPU env.
Yeah, but yeah. I okay, yeah. I always used to see.
If you go back now, you'll see it.
Yeah, that's why I wanted to like.
Sorry, refresh. Maybe it hasn't loaded. Just refresh.
Because you should see it in the actual menu. Oh yes. Okay, good. That's great.
Okay, so we're going to make a slight change to this repository to make sure we don't shoot ourselves in the foot. And this is a very good practice where you have a branch, kind of like a God branch, that serves as a trunk. So it will be the source of truth for the project. And that will be the branch that you use when you have to present your work to your supervisor, your manager, because it's stable. And then you have all these other work branches that are kind of temporary and they contain work in progress. So to stop people from just pushing unstable code to that stable branch, which in this case is the main branch, we're going to tell GitHub by changing some setting to not allow that happen. So it will not allow pushes to go to the main branch. Okay. And to do that, you go to your settings tab up there. And I think we need to do a little searching. I'm not sure where it is. So go to branches, maybe. Let's see. Yes. And I think there's an add rule. It's been a while since I did this.
Yeah.
And then at bottom there's require pull request before merging. And it will make sense because we're going to demonstrate what a pull request means. And there's a checkbox that says require approval. So a pull request here would be, so that I don't keep you waiting, a pull request here would be that now that Mehran has made a change, right? He's going to tell his collaborators that, hey, I have made some changes. I want you to pull the changes I've made and add them to the main branch. That's what a pull request is. An approval would be that pull request will not go through automatically unless at least one person says it makes sense what Mehran has done. And that creates sort of a layer of protection around the repository to make sure you don't have stray code or disastrous or deleterious code going in there. Okay. Okay, cool. So yep, so let's leave it at that for now. Just you need to save it.
So this doesn't need to be filled?
No, that doesn't need to be changed.
Okay. Oh.
Okay.
I think that star means we have to fill it.
Yeah, so maybe add main in there. Good. And then create.
Oh no. Oh no.
Would you have to do that? You can, okay. I hate it when it asks for passwords, but it's doing the right thing.
Oof.
Okay.
Thank God it worked.
Yep, it did. Okay, cool. Stop. So now our main branch has protection. We can't just send pull requests to it, and we can't just commit to it and push to it. We need to create pull request. So now that Mehran has made these changes, can you go back to the code tab there, which is the first tab, and then compare and pull request, the green button there. So what you're doing now is you're creating a pull request. It's good practice to add some text to it, but because, for this purpose, it's really a minor change. We're going to keep it as it is. So you simply hit on the create pull request button. Okay, so you can see it's saying that Mehran can't just push or merge this code. Even though it's his repository, he can't merge the code until someone else reviews it. And when you do that, sometimes it's helpful to assign someone to help you. Oh, because this is repository, GitHub is allowing him to bypass it. Oh, so unfair. But anyway, so let's pretend that part isn't there. Can you go to the upper right?
Sorry. Yeah. So what happened? What did GitHub allow me to do? I didn't see what you were talking about.
So you own the repository.
Yeah.
But what we've done is we've created a rule that stops anyone from pushing a pull request or automatically accepting a pull request without a review. So if you make a pull request, it must go through a review process before it's merged to the main branch.
Yeah.
But because you own the repository, GitHub is giving you privileges that allows you to bypass that rule, which is convenient, but it's not very common.
But where is this allowing me? Where?
So that checkbox there.
Merge I can check it.
Yes.
I can just. Oh, okay. Sorry. Okay.
Yeah. So you can cheat your way and push code without me knowing. But let's pretend you don't have that checkbox in there. What you will do is if you scroll to the top, okay, and go to reviewers, there's a gear button. It's on the right hand side or left hand side. I'm not sure. The very end. No, keep going.
Viewers.
Yeah, down there. Can you see gear button? Yeah. No.
Gear.
So there's a panel to the left. Sorry, to the right, because to the right, extreme right. Okay. Come down. I'll just show you. I'll share my screen and show you.
Okay. What's the keyword?
Search for reviewers. There. Do you see it?
Okay. This. Sorry.
Yes.
Sorry.
Yeah. It's so tiny there. It's hard to describe distance. Okay. And you can select me there. So what you're saying now is you're telling GitHub to send me an email. You can click away anywhere else and that will close. So what you'll do is it will send an email to me asking me to review the changes you've made. That's what's happening in there. And so I'm going to take over if that's okay.
Yes.
Just to show what happens when
you should be able to. So while you're sharing, by the way, while you're doing your side, I just want to let everybody know that first of all, if you have any questions, please just pop them in the chat. We'll get to all of them. And also, please make sure you like, subscribe, and share. Share is more important to me personally. That so many people would actually take advantage of these videos because they've been more than oh my god useful for me personally. So yeah, absolutely.
Okay, so here's notification from GitHub asking me to review Mehran's work, and it's saying that Mehran has made a commit, and the files have been changed as this, and this is the diffs and the patch, and he's requested a review on that bit. So what I'll do now is I'll just click on the view pull request, and this is how I go about reviewing pull requests. The first thing is to read up on the description. Mehran hasn't provided one because I know we collaborated on this particular change, but on a very serious project, it's important to put enough details in here because you're going to save the person a lot of time trying to figure out what you've changed. Then I'll go through commits. I don't usually do this, but I don't spend too much time. It's just to kind of check at a very high level how long you've been working on this. Okay. I'm going to skip on this because we don't have any checks, but sometimes we do. We'll get to that later on in this module. But what I'll do is I'll spend a lot of time here in the files change because it tells me that environment-gpu.yaml file did not exist in the past, but all these green lines there are things that Mehran has added. Okay. And I can start reviewing now and say, Mehran, I need more stuff to be done to it. I can just give a general comment without approving, but I like what he's done. So I'm just going to say, okay. So what that means is let's get this merged. And then I'm going to submit it.
That's like a universal acronym.
It's very common.
Okay.
Sometimes it means it looks good to me.
Okay.
So I could merge it, but it's always good practice to let the person who created the pull request to merge. But in the interest of time, I'll go ahead and merge it. The reason why it's good to let the person who created the PR to merge is because it's very likely that at the last minute, you realize that, oh, there's something you should have added to that PR, right? So you can open that PR again, make changes to it, and then ask for another approval. But if I merge it, you just kind of mess it up. You mess up the flow a little bit. So it's not a good practice. So I'm going to help you merge this. Okay, just to add more text in there because sometimes it helps to search for stuff.
Okay, so it's actually environment-GPU, isn't it?
Yeah, it should be environment.gpu, but it doesn't matter. I just wanted to say it's creating the environment file. Yeah. Okay. So the branch doesn't have to be alive anymore. It's done. It served its purpose. So let's just retire it. We're going to delete that branch. Yeah, there's no point having it lingering around because we can always restore it when we want to. Okay, so there. So if we go back to the repository and have a look, we have our environment.gpu file, we have our environment.yaml file, and every other stuff in there, just that has been there still the way it's supposed to be. So I'm going to now create a very lightweight wrapper around the 2 bits in there that allows us to make commands. And then I'll make a change. I'll push that change to GitHub. So I'm here now, which is the repository on my machine. It doesn't have the changes from upstream, which is GitHub. Anytime I say upstream, it's just a fancy way of saying GitHub, okay? So it doesn't have the change upstream. So I'll check that I'm in the right directory. Yes, I am. And then now I want to pull those changes. So I'll do a git pull, okay? In many cases, I tend to pull all the branches. And then, excuse me, the prune command or the prune flag will tell Git to delete all the branches that are still locally. So if I had a branch that I was tracking by Mehran and Mehran no longer needs that branch and he deleted it upstream, I want those changes to be reflected locally as well. So not just pull new branches, but also delete old branches, if that makes sense. So,
sorry, so does it mean that if, let's say, you had branch 1 and branch 2 locally, because that's what you had pulled from GitHub, and then certain changes are made and branch 2 has been eliminated from GitHub, by adding this prune, you're saying that, okay, if you see that I have like branch 2 on my machine, for example, but it's not on GitHub, prune it, get rid of it.
That's exactly what it does.
Okay.
Yeah. So let's make it work. Okay, cool, stop. So what it has done now is it's fast forwarded. So it's kind of moved forward in time to what Mehran has, because if you think about it as a timeline, I'm kind of behind the changes Mehran has done. So we just kind of fast forwarded to Mehran's state. And in doing that now, the environment.gpu, environment-gpu.yaml file has been added, okay? And I'll just check. We'll have just one branch in there. So what I want to do now is I want to create a makefile, okay? And what a makefile does is it runs, it's just it's a command that allows you to create build scripts. And what build scripts do is it's hard not to define these things in a recursive way. I was going to say that build scripts allows you to create build scripts, but that would be really silly. So what makefiles are very similar to batch files. They are similar to Python modules, but they are more similar to batch files than Python modules. But they have these sections, and each section contains a set of instructions that helps you build or set up your environment. So you can choose to run all the sections, or you can choose to run some sections. So one section could be download PyTorch, another section could be install PyTorch GPU, another section could be install PyTorch CPU. And then you could choose to run all three sections, or you could choose to cherry pick and run one or two sections. So that's what a makefile is. And the entry point for a makefile is the make command. So when you have a makefile, we don't have a makefile now. The makefiles are normally named makefile. So we're just going to touch that makefile. Okay, so now that makefile is there. And we know because here it is. Okay, the next thing now is to edit that makefile and make it executable, because makefiles require permission to do that. So we're going to do okay, that's makefile. And you may be wondering, what's this change mode plus X makefile? What I'm doing is I'm changing the file mode of makefile to be executable. That's what it is. But I'll give you a tool to help you understand the differences. It's called so you want to bookmark this, this website. And what you do is you take your shell commands and paste it in there and ask it to explain it to you. So it gives you this very visual explainer. So it's telling us that it's changing file mode bits, and then the plus X there. I'm surprised this doesn't have a lot of information, but in most cases, it tells you the options you can provide and what each of those options mean. So this is one of them. I'll post this on Discord. There's also a too long didn't read. So I don't know if I installed it here. Okay, I have it. So okay, let's not get into it. I think it's going to create more. I'm just kind of looking at time for that. So anyway, we have our makefile. So I'm just going to enter into that makefile. And then I'm going to have a section called install CPU. Okay. And the install CPU is going to simply be the conda command that you created previously. Conda create environment. Conda environment create, and then we give it environment YAML file. And then we have the install GPU. And then this will be conda env create. GPU YAML file. Okay. And then we could decide to use all, but I think it's just, let's leave it plain and simple for now.
Sorry, Khalil, just for 1 second. I think that there's an issue with the live streaming.
Okay.
Just 1 second. I'm not sure what's wrong. Just 1 second. Just 1 second. Or maybe it's working. So yeah, maybe I think it's working. It just YouTube is giving me weird messages, but I think it's working. Sorry
Okay,
for interrupting.
that's fine.
Go on.
Okay, cool. So all I'm doing now is I'm going to save it. Okay, and if we look at the make file, there's nothing fancy. There's just install CPU, conda-env. It will run with create using this file environment.yaml file. Alternatively, to use conda GPU in there. Okay, so now that we have it,
can you just say something?
Yep.
There's that question mark on the top of the prompt. What is that?
Which question mark? You mean the arrow there?
No. The line above, yeah, right after the main branch word, yeah.
Oh, it means that I have changes that are not committed yet. It's just a way to say that, you know, it's a sign telling you that you have changes you haven't committed yet. And you can get that prompt file as well. So it's called spaceship prompt. So I'm going to send that also on Discord in case you're interested in it. You also get that on Windows as well. So it gives you, you know, very neat features and GitHub and all that kind of jazz. So I'm going to send that on GitHub as well. Okay, cool. So now to test that it works, I'm going to delete my VAE environment. So I'll deactivate the environment first. And once I do that, VAE has changed to base. So I'm now in the base environment. And then I'm going to delete my environment. I'm going to delete my environment. And that should take a second, hopefully, to run. Or maybe more than a second. Okay, so now I don't have one. If I list the environments on my machine, I have two, which is base and test. So I'm going to attempt creating using the make file now. So remember, I have this make file, which is new. So I'm just going to do make, okay? And then I'm going to do install CPU. And that installs it for us. Now, this is just a starting step. Ideally, what should happen is we should simply just say make install, and it should figure out if I have a GPU, then install the GPU, or if I have a CPU, then install the CPU. But because this session is a short one, hopefully in the future we'll change the behavior of the script to get it to work in that particular way.
I mean, you'd think it's a short one, but it's already an hour.
It is. Time flies, you know. At some point, maybe we might consider doing more frequent sessions as opposed to waiting for an entire week to get things out there. But now I like the speed, and I'm open to feedback. So if you're watching this, tell us, do you like how slow or how fast we're going? Do you want us to expand on certain things? Do you have any concerns about our approach? Just give us feedback. We are yearning for it, okay?
Yeah, exactly. So on our Discord, we have multiple threads, or let's say multiple channels is the right way. Especially there's one channel called feedback where you can actually give us your feedback. And yeah, also I'm gonna send the link here in the chat. So this is how you can connect with us on Discord as well. Okay, so just check out the chat box and join us.
Yeah, please do.
Yeah.
So yeah, our environment has worked. All we had to do was just run the make command. So we're off to a good start, and I'll do a git diff to see if there's any changes. Looks clean to me. So another git status, our make file is there. So the next thing I'll do now is I'll try and package my changes into a PR, send it off to Meheran, and hopefully we can wrap this session off. The first thing I'll do is I'll create a branch for my PR. And to do that, because I'm old school, I use a git checkout command, but there's actually a branch command. You want to look that up. It's very recent, maybe a year or so. Old habits die hard. So I'm using the git checkout command, and then create makefile. That'll be the name of my branch. That branch has now been created and I've been switched to that branch. And if I run a git branch command, you'll see I have two branches and the green one is the active branch at the moment. Okay, so we do have a README file, but the README file, it's nothing to write home about. It's just stuff. But now we have a standard way of installing. So let's edit this README file a little bit and say we have installation instructions now. We'll come back and fix this.
Yeah, it doesn't matter at this stage. It's just showing how it's done.
Okay, so so now we have two changes. Okay, I modified readme.md file, and then I also added the make file. So I'm going to push these two files from my working directory to the staging environment and this place where we're trying to get ready to make snapshots of it. Staging, and you can see that there. And I can do a git commit m. And then I can push. So I have the same error Mehran had. So I'm just going to change that, copy, paste. Oh, it's asking me for a push. Okay, so yeah, I forgot I haven't authenticated this particular tool. So what I'm going to do now is I'm going to, yeah, I have visitors. Say hello, Zaid. Let me take him. I'll be right back.
That's the beauty of working from home.
Yeah, the beauty, the joys of working from home. Yeah, so I'll join them in a second. Good. They know I should be done by 5 o'clock, but it's fine. I'll soon be wrapping up. Okay, so I'll use the GitHub desktop tool. And what it's doing at the moment is I'm in the VAE environment, and I'm only using this tool because I haven't set up my terminal to work with SSH or HTTP authentication, and because I can't remember my password, which I should look it up. So now that our changes have been saved, we can look at the history. This is what I've done just now. The make file is there, and also the README file is also there, right? This was the changes from Mehran. You can see ML Dawn. This were the previous changes we've had. So all I'll do now is just publish this branch. Okay, and then I can create a pull request from it as well. So what I've done is I've added a make file. And I think I'm going to leave this empty because I can always come back and edit it as well.
Yeah.
I'm going to assign ML Dawn as the reviewer. And then I can create the pull request. So what this will do is it will tell Mehran that I want to merge the changes I've made, which is the commit, into the main branch from create make file. Okay. And Mehran hopefully should be able to skim through this review, hopefully, and accept those changes. So there. So
so let me just share my screen and finish it.
Okay.
That's great. This is where I am, right? So if I go here.
You want to go to pull requests?
Okay, pull requests.
Are you sharing your screen? Okay, I can see it. I can see it.
Yeah,
my mistake.
So this is the one.
Yes.
And this is not, okay, this is the one. So I have to click on this, right?
Click on files changed. Okay, it takes you there either way.
Okay.
Yes. So just
So
kind
we
of
have
skim through.
make file, good. So I can add, review, whatever, remove. And if I'm okay, where should I go? Here? Yeah. You're on mute, by the way.
Sorry.
Yeah.
So you click on approve.
What was it?
Let's get this merged. Cool. Welcome to the club. Yeah. Yeah. Awesome. Okay, so
and I need to merge it now physically.
I'm going to merge it. I'm going to merge it. So
okay.
And if you're still sharing your screen, hopefully you'll notice that the status has changed on your end. But if you're not, it's fine.
Oh, did you just merge it?
I just did.
Okay, so just one second.
Yeah.
I just stopped sharing for a second.
Yeah.
Okay, so approved these changes.
Yes. So they are approved now.
Okay, so I'm finding it a little bit difficult to understand this list, like this sort of whole thing.
Yeah, so it's a timeline.
Yeah.
First of all, I made that file, which is a commit, and that's the commit ID there. And then I requested a review from you.
Then I approved it.
Then you approved those changes and you added a comment to your approval. And then I merged it. And then I deleted the branch.
Great.
Yeah.
Perfect.
It's beautiful.
I think that's it then.
I think that's it. But I think this is actually a good milestone because where we're at the moment is we now have wrapped up the process of creating a virtual environment, right?
Yes.
And we can take a dive into the meat of the project. And it might seem as if we've spent 2 or 3 hours setting up a virtual environment. And you may wonder why that's important. I think I've said it very early on that when you work in a team, the choice of setting up your local machine and trying to be in harmony with the people you collaborate with is extremely key. If you don't do that, what happens is 2 weeks, 2 months, 2 years into the project, when you come back and try and sort stuff out, you run into a lot of errors because there wasn't this common ground, this very solid foundation in there. And like building a real, structure, architectural structure, more time is spent in foundation at the lower levels than at the higher levels. And speaking of lower levels, what we've done now is we've built the technical low level to start the project, but Mehran will take over and build on that low level with more low level stuff with regards to BAE. So Mehran, tell us about it. What should we be looking forward to?
So I think that probably the next, beginning from next video, we will probably get started with looking at the data set, writing some code, visualizing by the way, it's going to be an image data set. So we'll be visualizing the images, we'll be looking at the dimensions of those images, get some statistics like how many images, how many classes, do we have missing values, do we have annotation, do we have labels, what sort of labels, and basically getting comfortable with the data would be I think the next thing that needs to be done. And after that, we will get into variational autoencoders. I think that it would make sense to get into the math of variational autoencoders and like how deep we will go. We need to think about like how deep we need to go, and so that we would provide you guys with enough understanding about what's happening, and yet without overwhelming you with too much stuff that might not be necessary, at least at the moment. But one of the things that that we were talking with Khalil about, like in terms of when it comes to actually coding variational autoencoders in PyTorch, it'd be good to have some sort of a side-by-side sort of screen where you guys can see the mathematical concept and then the actual translation to PyTorch to sort of implement that mathematical sort of concept. For example, like if I'm going to create a, let's say, a layer in my variational autoencoder, and so what kind of operations is it going to do? So you see the math on this side, like how it manipulates the data, and then you see the implementation of it on the left-hand side. If you're going to like see the mathematics of the error function of variational autoencoder on this side, you will see the implementation on the left-hand side. So that sort of correspondence between two beasts, I'd like to call them, that would help you guys to follow easier as to what's happening. And hopefully we'll see where it goes from there, but at least that's the vague plan in our brains at the moment.
Sounds exciting. And yeah, I'm really looking forward to it. That said, again, keep in mind that it's very likely that we may go back and make slight changes to the environment as we need to, but things are going to get really exciting from here on. So tell your friends, tell your colleagues, tell your family members, show up, okay?
Yes, exactly. Show up, be there, okay?
Okay, cool.
All right, so folks, thank you so much for joining us today, and many thanks to Khalil. Again, it was a pleasure, and I learned a lot, Khalil. Today for me was really like crazy.
I learned a lot too. Thanks for having me. It's such a pleasure doing this.
Cheers. Cheers. Bye.